Okay, today I want to make a video about solving exponential equations. Just basic, simple exponential equations. Okay, when you see the word exponential, hopefully you think of exponent. And an exponent is that small number, let's say you have 2, on a base. So you've got a base raised to an exponent. When students look at these types of problems, they seem to think that they're very difficult. But I want you to remember these are very, very simple in that I like to refer to them almost as if common sense. When you look at this first problem, you have a base of 5 raised to the 2x equal to a base of 5 raised to the 8th power. You have, look, 5 to the 8th. And you have an equal sign. Doesn't this have to be 5 to the 8th? So you're really just trying to figure out what x is that would make this 8. And that's the simple common sense side of it. But this is what I say when I teach it to students. When your bases are the same, I have a base of 5 on the left and a base of 5 on the right. When your bases are the same, that means the exponents are equal. So since my bases are the same, I can forget about them. 5 is irrelevant in this problem now. And I can say 2x is equal to 8. And I solve that linear equation. I'm going to divide both sides by 2. So x is 4 to make that a true equation. 2 times 4 is 8. That's the answer to that first exponential problem. Okay, here's the next one. I guess basically the first thing you're going to ask yourself, are your bases the same? And yes, this is a base of 12 and this is a base of 12. So since my bases are the same, I don't have to think about 12 again. I know that the exponent on the 12 on the left is equal to the exponent on the 12 on the right. So 3x plus 5 is going to equal negative 2x plus 20. Okay, let's solve. I'm going to move the smallest x to the largest x. 5x plus 5 is going to equal 20. Going to subtract 5. 5x equals 15. I'm going to divide by 5. X is 3. We can check to see if we're right. 9 plus 5 is 14. Negative 6 plus 20 is 14. So 3 is the correct answer. Now, look at number 3 compared to number 1 and number 2. Do these have the same base? No, they don't. So this is where it gets a little complicated, but not really. Can you rewrite one of these bases as the other? And really you're going to look at the larger base. Can I rewrite 16 with a base of 4? So can you raise 4 to some power to get 16? Yes. You can rewrite this as 4 to the second power. That's 16. And you can bring down this base of 4 to the x plus 2. Now, do I have the same base? Yes. So those 4's are eliminated from my mind. Now I know x plus 2 equals 2. I can solve that equation. X plus 2 equals 2. Get x alone by subtracting 2. 2 minus 2 is 0. So 0 plus 2 is 2. So that is the correct answer. Let's look at number 4. Again, not the same base, but can I make it have the same base? Look at my larger base. Can I rewrite 125 as 5 raised to some power? Well, 5 to the first power is 5. 5 to the second power is 25. 5 to the third power is 125. So yes, I can rewrite 125 as 5 to the third power. Let's do that. 5 to the 2x plus 3. Notice what I'm going to do next. 125 is 5 to the third power, and it already had an exponent out there of 4x minus 5. Okay, so I have a base raised to 2 powers, or 2 exponents. This is one of those exponent rules. You have a power of a power rule. What do you do to these two things when you have power of a power? Well, you multiply them. You have 5 to the 2x plus 3 equals 5 to the 3 times 4x minus 5. If you want to go ahead and distribute that 3, you're welcome to do that. I'm going to go ahead and say, okay, I've got the same base of 5, so I know that 2x plus 3 exponent on the left is equal to the exponent on the right, 3 times 4x minus 5. So 2x plus 3 is equal to that exponent. And again, you're welcome to go ahead and distribute, but I like to show every one of these steps. 3 times 4x, 3 times negative 5. And now I'm going to solve. I'm going to move the smallest variable to the largest. So 3 is going to equal 12x minus 15. I'm going to add 15 to both sides. So going up here, 3 plus 15 is 18. It's going to equal 12x. Divide by 12. Does 12 divide into 18 evenly? No, it does not, so I just leave it this way. Don't know what's wrong with me that I'm keep making that blend in together, but that's okay. So 18/12 is my answer, but can I reduce that? Yes, both of these are divisible by 2. They're also divisible by 3, but they're also divisible by 6. So I'll go ahead and do 6. X is going to equal 3 over 2. If you want to put 1.5, fine, but I just think it's better the higher you go in mathematics to leave your answers as an improper fraction. Okay, so let's go on to number 5. Interesting. Can I rewrite 64 with a base of 16? 16 to the first power is 16. 16 to the second power is 256. So no, I can't rewrite 64 with a base of 16. So that means I'm going to have to find a base that I can rewrite both of these as. And if you think about it, a lot of students will think 8. 8 to the first power is 8. 8 to the second power is 64. So you can't use 8 because you can't get 16 by 8 raised to a power. Okay, so then that means I'm going to have to go smaller than 8. How about 4? Okay, we know 4 to the first power is 4. 4 to the second power is 16. 4 to the third power is 64. So look, right there, right away, I got 16 and I got 64. So 64 is 4 to the third power, and 16 is 4 to the second power. Okay, so there's those exponent rules again. You have power of a power. So you're going to multiply. I think I'll go ahead and multiply. You're going to distribute 3 times x and 3 times 4. So you have 3x plus 12 equals, you're going to distribute 2 times 4 and 2 times 5. So you're going to have 8x plus 10. Now, do I have the same base? Yes. So then that means that an exponent of 3x plus 12 is equal to the exponent of 8x plus 10. Then I'm going to solve. I'm going to subtract the smallest x to the largest x. 5x plus 10 on the right. I'm going to subtract 10. 12 minus 10 is 2. Then I'm going to divide by 5. Does 5 divide into 2 evenly? No, it does not. So I'm going to leave 2/5 as the answer. And that is the answer to that one. Okay, now let's look at the last one. I've got one more, then I'm finished with this lesson. Okay, now again, we have two different bases. 36 to the second power. I do not know that off the top of my head. I do not believe, though, it's 1,296, but we'll multiply it out to see. 6 times 6 is 36. 18 to 16. 3 times 6 is 18. Maybe it is. 3 times 3 is 9, plus 1 is 10. Oh, I think it is. 6, 8 plus 1 is 9. So 1296. Yes. That 36 squared is 1296. Okay, so then I can leave this as 36 to the 3x plus 5 equals 36 squared. Okay, now I have the same base, so I know 3x plus 5 is equal to 2. I'm going to subtract 5 from both sides. 3x is equal to negative 3. Divide both sides by 3. X is equal to negative 1. There we go. That's the conclusion of solving basic exponential equations. There are times when you cannot get the base the same, and that's when you get into using logarithms, but that's for another lesson and another day.